everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम लोग कंप्यूटर नेटवर्क की क्लास करने वाले हैं जो कि क्लास नंबर 4 है आपका. ऑलरेडी हमने 1 2 3 क्लासेस कर लिया है जिसमें हमने यूनिट 1 जो थी वो कंप्लीट कर लिया है जो कि इंट्रोडक्शन कॉन्सेप्ट था. आज हम जो स्टार्ट करेंगे वो सेकेंड यूनिट से स्टार्ट करेंगे जो कि मीडियम एक्सेस सब लेयर है. And hopefully in the next two classes, next coming classes, we will end up with this only. And first of all, it's a huge request from my side to all of you, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Now we'll start with the medium access sub layer here, and that is we'll start with the channel allocation. With this channel allocation here, in the channel allocation, the first question they can ask you about 5 marks, that is, what are the major problem in allocating the channel here. So in that the static channel allocation and the dynamic channel allocation, they are the two types, and that what we will discuss one by one. And the major problem that is allocating in the channel is the static allocation. So I will just write it down. The first is static channel allocation, and the second one we have is your dynamic channel allocation. In the static channel allocation, in the LAN, number of the workstations are operating and only one user is allowed to broadcast on the channel. First way of allocating a single channel among the multiple competing user is by using frequency division multiplexing, that is FDM. For the n number of the user, the bandwidth is divided into the n equal portions, and each user being assigned one portion. And since each user has a fixed frequency band, and that was with that band interface between the user is avoided, and this is applicable only when the number of the user are less and each have a constant traffic. With the regard of static channel allocation here, that is when the number of users are large and a continuously varying traffic, then the bandwidth is divided equally into n regions, and if less number of users, that is less than n, that want to communicate, and a considerable portion of the frequency spectrum is wasted here. If the large number of the user, that is greater than n, then want to want to communicate, some of them will be denied permission due to the lack of the bandwidth. In this case, the channel is said to be inefficient here. In the regard of fit, if I'm talking about basically that if all the user who wants to communicate are arranged in one queue, and number at users are n, and then the average delay, that is t, that will be the n times, and then that means that the time delay, and thus the static FDM exhibits poor performances of a channel here. In the regard of it, if I'm talking about the static here. Now I'll discuss about the dynamic channel allocation here. In the dynamic channel allocation, the dynamic channel allocation method is incorporated in all the LANs and WANs, that is WAN as wide area network and local area network. And the dynamic channel allocation method that can handle all the type of the traffic condition. A discipline is built up amongst the stations of the LAN, that is local area network, and so that the fair opportunity is given to each station to transit its data frames. And for this, following requirements are to be fulfilled by the local area network. That is, the first is that the workstations or the terminals are independent and the work is generated at a constant rate, that is independent traffic. The second is a single channel is available for all the communication, and all stations can transmit and receive through it. And the third is that if these two stations are transmitting simultaneously, the single signal collide with each other and resulting signal is grabbed, and this process is called collision, and this collision can be detected by the all station, and the collided signal may be retransmitted as well. In the regard of it, if I'm talking about, moreover, that is the workstation that can be begin in single transmission at any time, or any slotted time that is assigned to it. And after that, for the dynamic channel allocation, that the station can have either carriers sensing or not, and the carrier is a specific electrical signal on the network, and sensing of the carriers gives the status of the channel, that is the busy or a free. Now we'll discuss moreover related to that, discuss the medium access control scheme, that is basically in the reference towards the unit as well. So we'll discuss medium access control schemes. So medium access control schemes here. So in the medium access control schemes here, in the reference towards it, that what we have to discuss here. This has also been asked 5 marks, and according to this, that the medium access sublayer is the bottom part of the data link layer, and the medium access sublayer is also known as the MAC sublayer, that is your medium access control, जिसे हम MAC बोलते हैं. In the reference towards it, when a common medium is shared by many stations, that is your medium access control layer plays a very important role. Without this control, several without these control, if I'm talking about, without these control sub level, or there are the several stations that transmit the simultaneously, could produce the garbed message as well. And the media access control mechanisms standardized by IEEE and are implemented in the MAC sublayer of the data link layer, and it provides the services to the LLC, that is your logical link control sublayer, and that receives the services from the physical layer below it. And the basic function of the MAC sublayer is the media access control, error detection, and the station addressing as well. The physical transmission media of the local area network is shared by the station connected on the LAN as well. And the media access control procedures are implemented to ensure that every station gets a fair chance to transmit, and collision do not take place. There are several methods of media access control in the LAN, that is a local area network, and each method is applicable to a specific LAN topology. And in addition of the basis access procedure, the MAC layer also handles the frames that are delimiting the address recognition and the error checking function as well. In the regard of it, if I'm talking about here with reference towards the medium access control scheme, that is MAC scheme, when the number of the users stations share a single transmission medium, and this is called a multiple access communication, and the transmission medium is broadcast in nature, so all other attached station to the medium that can receive the transmission from any other station, any given station here. The two basic approaches to medium access control are random access and scheduling, and that illustrate with approaching the sharing and the transmission media, here, that is the media sharing, that has been divided into two. The first is static allocation, the second is dynamic medium access control. And the dynamic medium access control has been divided into two. First is scheduling, and the second is random access. So this is a sharing or transmission media here. This is a sort of a flow diagram, and now we'll discuss. You have to transit answer the following multiple access protocol. We'll discuss multiple access protocol. In the multiple access protocol, while we are discussing this here, with this that a pure Aloha network transmitted 200-bit frames on shared channel of 200 kbps. What is the throughput if the system, all the station together, provides 250 frames per second, And the second part they can ask you, how can you compare pure Aloha and a slotted Aloha, which is very 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 important, that we will discuss here as well. This has been asked of 5 marks, 2.5 ये वाला और 2.5 difference comparison between pure Aloha and a slotted Aloha. And that is very important क्योंकि बहुत सारे बच्चों ने मुझसे इस बारे में पूछा भी था. And I had told them कि okay, I will be, when I will start with computer network, I will be telling you about Aloha, and that is as well as important. So let's go ahead with the question. So इसको दो पार्ट में करके दिखाते हैं, so that we'll discuss that. A pure Aloha network transmits 200-bit frame on shared channel of 200 kbps. What is the throughput if the system all station together reduces to 50 frames per second? Again, the second part is how can you compare the pure Aloha and the slotted Aloha, that we will discuss as well in deep here. So for this we have a solution here, that what we have to discuss, that is your in the terms of it, that is your the transmission rate to 50 frames per second. So the transmission rate to 50 frames per second, that is throughput, S equals to G E minus 2G, and its frame transmission is, that is your 200 upon 200, that kbps, that, or you can say that 1 ms. And the reference towards it, if the system create 250 frames per second, this is 1/4 of the millisecond, the load of 1/4 in the case that we have S equals to G multiply E minus 2G, S equals to 0.152, 15.2%, and this means that the throughput is 250 multiply 0.152, and which is equals to 38, and only 38 frames out of 250 will probably survive. So this will be the solution, that what we have to do. Now we'll discuss about the comparison of pure Aloha and slotted Aloha here. Here we'll discuss about the difference between pure Aloha and slotted Aloha. So in the case of the pure Aloha and the slotted Aloha, we'll discuss more than 5 differences, and you have to write it down, more than 5 differences as well. For the pure Aloha here, the pure Aloha frames are transmitted at arbitrary times, and for the slotted Aloha, time is divided up to into the discrete slots, and the frame is sent at the start of that slot here. With the second differences, that is your throughput S equals to G multiply E minus 2G, and for the slotted Aloha, the throughput is S equals to G multiply E minus G. And for the third difference is that प्योर अलोहा में e की पावर -2g होता है, जो कि हमने अभी फॉर्मूला यूज़ भी किया है, और स्लॉटेड अलोहा में दैट इज़ e की पावर -g ओनली. And the third difference is that the vulnerable time is 2 times to the frame transmission time, and for the slotted, that is the vulnerable time is 1/2 that of the pure Aloha. And for the pure Aloha, the maximum utilization is about 18.4%, and for the slotted Aloha, the maximum utilization is about 36.8%. And for the fifth one, that is a pure Aloha, that is global time is not required. And for the slotted Aloha, it requires global time synchronization, as it's divided up to into a discrete slot. And with the sixth differences we have here is your that is your simple to implement, that is of pure Aloha. And for the slotted Aloha, that is implementation is a complex due to the synchronization of all the nodes, that is for the slotted Aloha here. The seventh difference is with that is we have a pure Aloha here, that is cannot use for the satellite due to the very low utilization. And for the slotted Aloha, that is it is used in the broadcast satellite as well. Now we'll discuss the another one, that is this, we had discussed the 7 differences between pure Aloha and slotted Aloha, and now we'll discuss different carrier sense protocol, how they are different than a collision protocol, that what we'll discuss about it. And that is different carrier sense protocol. Here in this, that is a carrier sense multiple access, that is CSMA, which I told you about, that is carrier sense multiple that is access. This requires that each station first listen to the medium before sending, and the CSMA can reduce the possibility of the collision, but it cannot eliminate it. The possibility of the collision still exists because of the propagation delay, and a station may sense the medium and find it idle only because the first bit sent by the another station has not yet been received. Three carrier sense protocols are non-persistent with the regard of it, that is persistent here. In the regard of it, the protocols are non-persistent CSMA, and the first persistent CSMA, and the P persistent CSMA, and all the three protocols are differing by the actions to be taken by any stations after sensing the readiness of the channel. And in the non-persistent CSMA, when a station is having a packet like frame to transit and finds that the channel is busy, it backs off for a fixed what we had talked about, that is of back off with the interval of time. And if then that it checks the channel again, and if the channel is free, then it transmit. And in the regard of it, if the channel is already in use, the station does not continuously senses it for the purpose of the sizing it immediately upon the detecting the end of the previous transmission, but it waits a random period of time and again checks for the activity. So for that we have here, that is the two persistent CSMA, and that is your first for persistent CSMA, and the second is the P persistent CSMA, that what we'll discuss here. First, persistent CSMA, and the second is P persistent CSMA. These were the two. In the first one, the first persistent CSMA here, any station wishing to transmit or monitor the channel continuously until the channel is idle, and then transmit immediately with probability 1, hence the name 1 persistent. And when 2 or more stations are waiting to transmit and a collision guaranteed, so since each station will transmit immediately at the end of the busy period, and in this case each will await a random amount of the time, or will then attempt to transit as well. And in the case of the talking, we have to talk about the persistent CSMA here, that is when a station becomes ready to send and senses the channels to be in idle, if either transmit with the probability here, and with that probability P, and it defers the transmission by the one time slot with a probability that is Q equals to P minus 1. P minus 1 that defines the slot is also idle, and the station either transmit the probability P or defer again by a probability Q, and the process is repeated, either packets are transmitted or the channels becomes busy as well. In the regard of it, now we'll discuss about the carrier sense protocol that are different from the collision protocol. In that CSMA scheme, the collisions involves the entire frame's transmission, and if the stations can determine whether a collision is taking place, then the amount of the wasted bandwidth that can be reduced by the aborting the transmission when the collision is detected. The carrier sends multiple assets with collision detection, that is CSMA CD, use this approach, and the CSMA CD stations waits a random period of time, and then that tries again, assuming that no other station has started transmitting it, and meantime frame transmission time must be 2 times the maximum propagation time as well. Where the CSMA is a medium access control, that is a MAC protocol, and where the node transmit data on the shared transmission media only after verifying an absence of other traffic. In the CSMA CD, collision are detected as they occur. The senders do not do not signal their intent to transmit, but simply start transmitting if they send no other ongoing transmission. Now we'll discuss about write a short note on the following: collision avoidance. Here with the regard of it, that is your collision avoidance. In the collision avoidance, the collision are avoided by the 3 method, and which we have here. The first we have is interframe space. The second we have contention window, that we'll talk about in detail as well. The third we have is acknowledgement. So these were the 3 collision avoidance here. In the reference towards it, that the diagram that shows this 3 method of CSMA and CSA, that what we have is your here, that it is we have time, this is time out, send frame, this is your, that is your contention window, then this is your busy, these were the continuously senses. And this last one will be your found idle. This is on the contrary, if we can talk about this, these were these were the size binary exponential, and that is your send frame timeout, and this is respect to the time as well, and this is what we have as your IFS. This is what it is, that is your CSMA-CA method. So in this we'll discuss one by one, that is interframe space, contentions window, and an acknowledgement here. So in the case of the interframe space here, that the collisions are avoided by deferring the transmission even if the channel is found idle. And when an idle channel is found, the station does not send immediately and it waits for a period of time called interframe space, that is known as IFS here. Okay. And when if in CSMA CA, the IFS can also be used to define the priority of the station of a frame, and a station that is assigned shorter IFS has higher priority. Now we'll talk about the contention window. In the case of the contention window are an amount of a time divided into slots, and a station that is ready to send choose a random number of slots as its await time here. With the regard of it, the station set one slots for the first time and then double each time. The station cannot detect an idle channel after the IFS time. In this method, the stations need to sense the channel after each time slot, and if the station finds the channel busy, it does not restart the process. It just stops the timer and restart it when the channel is sensed as idle. And this method gives the priority to the station with the longest waiting time. Talking about the third one, that is your acknowledgement. The data may be computed during the transmission, and the positive acknowledgement and the timeout that can help guarantee the receiver has received the frame. As what we had discussed, that the next we can discuss about it, how can you compare pure Aloha and slotted Aloha, as we had discussed this in the last class, and which is very important as well. So you can go through with that, because this has also been asked many times in the examination of 5 marks. And now explain about CSMA CD and CSMA CA with its and its uses as well. So that what we'll discuss here, CSMA CD and CSMA CA. With the CSMA CD, that is the full form of CSMA CD here. The full form of CSMA CD is the carrier sends multiple access with a collision detection. With the CSMA here, that is the carrier sends multiple access with a collision detection here. The basic protocol is that a station with a message to send must monitor the channel to see if the other station is sending, and if another station is sending, the second station must wait or defer until the sending station has finished. Then it may send its message, and if no station was sending at the time that it first listened, and the station may send it a message immediately. The term carrier sense indicate this listening before transmitting behavior. In this, if two or more stations have a message to send at the same time and they are separated by a significant distance on the bus or a channel, and each may begin transmitted at a roughly at the same time without being aware of that particular other station. So the signal from each station will superimpose on the channel and is gapped beyond the decoding ability of the receiving station, and this is termed as collision. A protocol that is required for transmitting the station to monitor the channel while sending each of its message, and to detect such collision with regard of it, I'll be showing you this. For example, this is in host A, this is host B, with this is data. this is of course data. This is collision occurred. This is host C. So this is a collision occurred, and this is a sort of a diagram which shows the CSMA-CD, that is your carrier sense multiple access with collision detection. With regard of it, when the collision has been detected, each of the sending station must stop transmitting and wait for a random length of time and then try again, because of a quick termination of the transmission time and the bandwidth is saved. CSMA-CD network works based on the burst multi-point topology with the bursty asynchronous transmission. All stations are attached to one path and monitor the single signal on the channel through the transceiver attack to the cable as well. The CSMA series supports both baseband and a broadband system. CSMA series has a totally decentralized control in the basis on the concentration of access, and CSMA CD is the most commonly used protocol for the local area networks. And CSMA CD network based on the burst multi-point topology with the bursty asynchronous transmission as well. Now we'll talk about the CSMA CA. CSMA CA, which it stands for carrier sense multiple access with collision avoidance. So here with the carrier sense multiple access collision avoidance, that is your multiple access with collision detection, and this is collision avoidance here. Okay, in the regard of it, that CSMA CA here, that is wireless network cannot use CSMA CD in a MAC sublayer, since this requires the ability to receive the transits the same time, and hence the use of the CSMA CA here as well. And with regard of it, in the wireless network, much of the sent energy is lost in the transmission, and the received signal has very little energy. Therefore the collision may add only 5 to 10% additional energy. This is not useful for effective collision detection. We need to avoid the collision on the wireless network because they cannot detect it, and so that CSMA and CA was invented for this network, that even though we had discussed in the detail as well. Now we'll discuss about a question here, that is, prove that for a slotted Aloha system, the maximum throughput happens at G equals to 1, where G is the number of the attempts per packet time, and that has also been asked of the 5 marks question. That what we have to discuss here. So here we have a question, prove that for a slotted Aloha system, the maximum throughput happens at G equals to 1, where G is the number of attempts per packet time. Solution. For this, we have in a slotted Aloha, the packets arrive in the synchronized fashion, and the probability of a single transmission during a slot time, we have P naught equals to E minus G, and we know that S equals to G E minus of G. The maximum throughput occurs at G equals to 1, where S equals to G के जगह पे हम 1 रखेंगे, so we will go ahead 1 upon E. E inverse है तो E of G, E of 1 हो गया. Like when we are putting 1, that would be like set of S equals to 1e minus 1. इस तरह से a inverse हो जाएगा तो 1 upon e and which is equals to 0.368. So which is twice that of the pure Aloha, and this means that the best channel utilization that can be achieved is around 37%. Okay. Now we'll go ahead with compare the delay of pure Aloha to slotted Aloha at a low load here, and that has also been asked of the 5 marks question paper as well. So that we'll discuss, and with regard of it, compare delay of pure Aloha and slotted Aloha and at low load. Okay, so with regard of it, if I'm talking about, which has also been asked of the 5 marks question paper here. So in this with a pure Aloha, the transmission can start instantly at a low load and no collision are expected, so the transmission is likely to be successful. With the slotted Aloha, it has to be wait for a next slot, and this introduces half of a slot time of delay, where we can say that in that same case, for the pure Aloha here, that is pure Aloha, and the delay equals to 2 into TP, and for the slotted Aloha, delay equals to TP here. And in this pure Aloha, the timeout period is equals to the maximum possible round trip propagation delay, and which is twice the amount of the time required to send the frame between the two most widely separated station, that is 2 multiplied TP. And where for the slotted Aloha here, that is the consequently the wasted time during due to the collision that can be reduced to 1 packet time, or the vulnerable period is reduced to half, which is mentioned here. Now we'll discuss a question here that on the basis of the Aloha as well. The question we have is, an Aloha network uses (19.2) kbps, and that is a channel for sending message packets of 100 bits long size. Calculate the maximum throughput for pure Aloha network. For this question is, and Aloha network uses 19.2 kbps channel for sending the message packets of 100 bits alongside. You have to calculate the maximum throughput for the pure Aloha network, and that has also been asked of in a 15, 16 or 5 marks, so that would we have to write it down as well. For the throughput S equals to G e power minus 2g, and for that we will put the value 0.0052 multiply e minus 2 into 0.0052. Then after that 0.0052 multiply e, will multiply this by 2, then we'll get 0.0104. After that we will solve the value of e की power 0.010 that is 0104 here in the reference towards it. So that is your 0.0052 multiply, we'll get 0.989653. when we multiply both, we'll get 5.14 into 10 to the power 3 minus 3. This is your value of that is the throughput, maximum throughput for the Aloha, pure Aloha network here. Now we'll discuss the channelization. In the channelization, we'll discuss the major problem with CDMA, and that is your code divided multiple access. So we'll discuss about the channelization. In the reference towards the channelization, we have to discuss the problem with CDMA. And the full form of the CDMA is code division multiple access. So problem with CDMA are as to be follows, that the overall performance degrades with the first is the overall performance degrade with the increase in the number of the users. The second is the time synchronization of the station is required. The third is that the guard band and time between the adjacent channel is required. The fourth is the code word is also required. And the fifth is each station is assigned a unique binary code, and this code is called as a chip code, and each stations and transmission is identified by its chip code here. That comes under the problems with CDMA. Now we'll discuss about the standard Ethernet. So standard Ethernet here. Standard Ethernet. In the standard Ethernet, we have to discuss about the Sche, the Manchesters, and the differential Manchester encoding, and for the bit of stream, that is your first we'll write it down for the coding that we have to do is for the Manchester encoding, and for the stream, that is for the bit stream, is we have 0 0 0 1 1 1 0 1 0 1 here. And for the Manchester encoding here, that is also been asked for the 5 marks question paper, that is Manchester encoding, and that for the differential Manchester as well. And for the Manchester encoding, what we have to do in the Manchester encoding, each bit period has both the high and the low voltage value. If the data is 1, the first half of the bit time is sent at the positive level, and the second half of the period is negative level. And for the data bit of 0, the first a negative signal and then a positive signal. So we'll draw that. This is that is a Manchester encoding. This is also a long 2-bit. Okay, so here this is 0 0 0 1, then again 1 1 0 1 0 1. So this is the Manchester encoding. Now we'll discuss about the differential Manchester. For the differential Manchester here, in a differential Manchester encoding, a binary 0 is marked as a transition at the beginning of the interval, and whereas at 1 is marked by the absence of the transition. And in this encoding method, detecting the changes is often more reliable, especially where when there is a noise in the channel. So we'll discuss that and we'll draw that as well. This is for the differential Manchester. So this is all, and that what we have to encode is 0 0 0 1 1 1 and 0 1 0 1 first. So this is for the differential Manchester here, and this is comes under the standard Ethernet. Now we'll discuss moreover about related to that, that is your what is the baud rate of the standard 10 Mbps 802.3 LAN, and you have to explain with that as well. So in that same case, for the baud rate that has been asked of 5 marks, what is the baud rate of the standard 10 Mbps 802.3 LAN? And with this the Ethernet uses the Manchester encoding, which means it has a 2 signal period per bit sent, and in the Manchester encoding the data is at a 1, and the first half of the bit time period is sent as a positive level, and the second half of the period is at the negative level. For the data bit of the 0, first a negative signal and then a positive signal here, and the data rate of the standard Ethernet is 10 Mbps, and for that we can find it out for the baud rate equals to 2 into data rate, and we have data rate 2 into 10, so that is 20 megabaud. Okay, that is the baud rate, and the baud rate is the number of the symbol per second, second transferred, and the baud rate specifies how fast data is sent over the serial line, and it is usually expressed in the unit of the bits per second, that is bps here. In the regard of it, in the reference towards it, now we'll discuss about explain the binary exponential backoff algorithm, that has also been asked of the 5 marks, or they can ask you explain the following protocol, that is the binary exponential backoff algorithm. So that we'll discuss here. Binary exponential backoff algorithm. So here in this that what we have to discuss, that is your binary exponential backoff algorithm. In the regard of it here, that has also been asked of the 5 marks question paper, and in the regard of it, that after a collision time is divided into the discrete slots whose length is equals to, in the reference towards it, that is the length of is equals to the worst case round trip propagation time of the either two t, like that we'll discuss after first collision, after second collision, after third collision, after ith collision or nth collision, what it takes place. So after the first collision, what it happens is each station was either 0 or a 1 and slot time before the trying again. If two stations collide and each one picks at the same random number, then they will collide again. So in this, after first collision, then after the second collision, what we see that each one picks 0, 1, 2, 3 at a random and waits that the number of the slot times. And then after that, after the third collision, if the third collision occurs, then the next the number of the slot to wait is chosen as random from the interval 0 and 2 to the power 3 minus 1. And even after ith collision, or you can say that after nth collision, random number of 0 to keep our e minus 1 has been chosen, that the number slot is skipped. So this algorithm, called the binary exponential backoff, and was chosen dynamically adapt to the number of the station trying to send here. With the regard of it, that will discuss IEEE 802.4, that is your token bus here. In the regard of it, that has also been asked of that is of marks, that is your 5 marks. So with regard of it, what is the problem encountered when IEEE 802.4 LAN as source is connected to IEEE 803 point LAN as destination? With the regard of it, the source LAN and the destination LAN, that we will discuss here. So here we will go ahead. The question I will be writing it out so that you will get it out what we are doing. What are the problems encountered when IEEE 802.4 LAN as source is connected to IEEE 802.3 LAN as destination? Okay, so here with this we have a source LAN, which is your IEEE 802.4, which they had mentioned here, and here this is destination LAN, that is they had given you IEEE 800, IEEE 802.3, and now here we'll be having, that is the size of the frame format. The second we have is size of the data field, and the third we have is minimum frame required. So with regard of it, for the source LAN, that is we have your 8202 bytes to 1572 bytes. For size to the data field is 0 to 882 bytes, and that goes to 0 to 1500 bytes. For the minimum frame required is your short frame size to 64 bytes. Now we'll discuss about the problem encountered and action here. That is, the first is that reformatting of frame required and requires a new checksum calculation. The second we have is that a different LAN has a different maximum frame length frame, and that are too large to be forwarded must be discarded, and in this case priority frame is to be discarded. The third is that the different LANs do not necessarily run at the same data rate, so buffer are needed to tackle congestions. And the fourth is that the token handoff acknowledgement delaying, that is represented. Now we'll discuss the another question that they can ask you is your draw and explain frame format for IEEE 802.4. That is draw and explain frame format of IEEE 802.4. With regard of it, that the token bus frame format, it consists of the following field type: number of octet, here we'll be having first, that is your preamble, that is one, then FSD 1, FC, then DA, then SA 228, then we have data 0 to 8 and 182, then we have FCS 4, and then ED 1. For these, for the preamble here, that is a bit synchronization. The SD is the frame start delimiter. The FC is here, that is a frame control. Then DA is your destination address. SA is the source address. Then data is a data field, and then FCS is your frame check sequence, and ED is the end dilemma. So this is all that what we have to discuss here in the reference towards it. And with the preamble, if I'm talking about in a detail, the preamble is an at least 1 octet long pattern to establish the bit synchronization here. And in the regard of it, the SD, that is the start delimiter is it is a 1 octet long unique bit which marks the start of the frame. The second and third is your FC, that is a frame control. The frame control field is used to distinguish the data frames from control frames, and for data frame it carries the frame's priority, and the frame control field indicate the type of the frame, that frame or a control frame here. For the DA, that is your destination address, the destination address field is 2 or 6 octet long. And for the SA, that is the source address, the source address field is also 2 or 6 octet long. And for the data here, that is, as I have told you about the data here. And the next is your FCS, that is the frame check sequence. That is, the frame check sequence is a 4 octet long and a content of CRC code, and it is used to detect the transmission error of the DA, SA, FC, and of course the data field. And where the AED here is your end delimiter, that is your, it is a unique bit pattern which marks the end of the frame. It is 1 octet long, and the total length of all the frame is your, that is total length 8191 octets. So this was 8191 octet here. And in the regard of it, if I'm talking about moreover reference towards it, so here the 802 point or performances for the token ring, the slightly higher delay compared to the CSMA-CD bus occurs, and for the higher transmission that loads the token ring performance as well. And in the regard of it, now we'll discuss about it, like draw and explain the frame format of IEEE 802.5. For that, we will go ahead with the IEEE 802.5 token protocol, that is, that consists of the following field, like your SD and AS, that is FC, and the DA. For the token frame is SD, AC, ED. This is 1 byte. Okay. And for the data frame, that is SD1, AC1, FC1, DA 2/6, SA 2/6 data. इसकी कोई लिमिट नहीं है, नो लिमिट. FCAS, that is 4, ED1, and FS, that is 1. This is in byte. Okay. So in the reference towards it, if I'm talking about in the detail, as we can go through with that as well. So in the reference towards it, when we are going to in the detail, that is the first is your SD, that is your start delimiter. In the start delimiter here, that field marks a beginning of the frame, and it is in 1 octet long unique bit pattern. And for the access control here, that it is one of the octet long field containing the priority bit P and token bit T, monitoring bit M, and the reservation bit R. With the regard of it, the frame control here, that is your frame control FC, that is one of the octet long field that indicates the type of the frame, data frame, or the control of frame. It is also distinguishes that control frame as well. The destination address is that the destination address field we have 2 or 6 octet long. And with regard of it, the SD stands for start dilemma, AC stands for access control, FC stands for frame control, DA stands for destination address, and then SA stands for the source address, and then data stands for the data field as well. The FCS stands for the frame check sequence, and ED stands for the end dilemma, and of course the FC stands for the frame status. Yeah, this is the format of IEEE 802.5 frame. For the source address here, that is the source address field is also 2 or 6 octet long. The data field, it can have 0 or more octets, and there is no maximum size, but the frame transmission time is limited for a token holder timer. And for the FCS here, that is the frame check sequence is 4 octet long and contain the CRC code, and it checks the DA, SA, FC, and a data field. And dilemma, that it is one of the octet long and that contains a unique bit pattern marking the end of the token and the data frame. And then we have here another one, that is your frame status, and here that this field is 1 octet long and contain a unique bit pattern marking the end of the token, or that of the data, and that the data frame here. Now we'll talk about token ring performances. In the token ring performances, when the traffic is light, the token will spend most of the time ideally circulating around the ring, and when the traffic is heavy, there is a queue at each station, and the network efficiency that approach 100% under the condition of the heavy load. Now I'll talk about less the potential ring problem in 802.55. So here we'll discuss about the potential ring problem in 802.5. So here there are the numbers of problem with the ring topology. The first is the a break in a link or a repeat of failure disables the entire network, and the second is the installation of the new repeater requires the identification of the two topological adjacent repeater. The third we have can face is your, that is the deviations of the clock, that is the timing jitter. And the fourth is, since the ring is closed loop and a packet will circulate indefinitely unless it is removed. And the fifth is, each repeater adds an increment of delay. And the sixth is, there is a potential limit to the number of the repeaters here. Now we'll discuss about the differentiate between 802.3, 802.4 and 802.5 IEEE standard. That has also been asked of a 5 marks question paper here. So that we'll discuss here. Differentiate between 802.3, 802.4, 802.5. So we'll discuss the differences more than, this has been asked of 5 marks, so this is important. So we'll talk about more than 6 to 7, or we can talk about the differences that are more than 7 as well, that is 8. So we'll discuss one by one. For the first difference, for the 802.3 here, the size of the frame format is 1572 byte, and that is your. And for the 802.4 here, the size of the frame format is 802,002 bytes, and for the 802.5 here, that is a variable size here. Okay, so in this case, the another one, the size of the data field is 0 to 1500 bytes. For the size of the data field is that is 0 to 8182 bytes, and for 802.5 that is no limit. And the 802.3 में जो कि थर्ड डिफरेंस है आपका, दैट इज़ नो प्रायोरिटीज़. 802.4 में it supports priorities, and 802.5 priorities are possible. This is the third differences between. And the fourth differences is that 802.3 has no deterministics. 802.4 में that more deterministic than 802.3, and it does not have. And for the another fifth differences we have is that 802.3 में minimum frame required is 64 bytes, and for 802.4 is it can handle a short minimum frame, and for 802.5 it supports the short frame here. So next, the sixth differences we have is efficiency decreases when speed increases, and the collision affects throughput. And for 802.4, the throughput and the eligibility at a high load are excellent. And for 802.5, the throughput and the efficiency at a high at a high load are excellent. The seventh differences is that the modems are not required, modems are required, and modems are required here as well. The eighth and the last differences among all, that is the protocol is simple, protocol is extremely complex, and protocol is moderate complex here. So these were the 8 differences that has to be very have to know about it, and you can just write it down, and if you are making the notes, then that is benefit for you as well. Now we'll discuss about the wireless 802.11, and that is the wireless 802.11, that what we'll have to discuss in the detail as well, and that what that has also been asked, and that has of marks of 5 marks they had asked you, so that we'll discuss in the detail here. That is your wireless 802.11, which comes under IEEE 802.11 standard. So here, with regard of it, we can say that the wireless network uses the unguided media for the transmission, and the receptions are achieved by the means of an antenna and the atmosphere and the other space, and the examples are unguided media that provides the means of the transmitting electronic signals but do not guide them. This form of the transmission is usually referred to as a wireless transmission. 802.11 refers to a family of specification developed by the IEEE for the wireless LAN technology, and there are the three specifications of the families: 802. That is 11, 802.11a, and 802.11b. And where specification of 802.11 family that we have here is for the 802.11 here, that is, it is a wireless LAN and provides the 1 Mbps and 2 Mbps or 2 Mbps transmission in the 2.4 gigahertz band, and it is uses frequency hopping spread spectrum, that is FHSS, or the direct sequence spread spectrum, that is DSSS here. For the 802.11a, it provides up to 54 Mbps in the 5 gigahertz band, and it uses the orthogonal, that is the orthogonal frequency division multiplexing encoding scheme. The next we have is the 802.11b. In this, that is it also refers to a Wi-Fi. It provides 11 Mbps transmission in the 2.4 gigahertz band, and 802.11b uses only direct sequence of static spectra. इसके अलावा भी एक और है 802.11 की फैमिली, that is your G11G, that it provides a 220 Mbps and more than in the 2.4 gigahertz band. In reference towards the 802.11 LAN is based on the cellular architecture. The system is subdivided into the cells, and each cell is controlled by a base station cell, and called as basic services set BSS, and the basic base station is access point, that is AP. The wireless LAN can be formed by a single cell with a single access point. IEEE 802.11 defines the three types of station based on the mobility in the wireless. That the first we have here no transition. The second is we have is your BSS transition, and the third we have is your ESS transition. So here, a station with no transition mobility is either stationary or moving only inside a BSS, and a station with BSS transition mobility that can move from one BSS to another, but the movement is confined inside the ESS here. In the regard of it, if I'm talking about the station with ESS transition mobility that can move from one ESS to another, and IEEE 802.11 does not guarantee the communication that is continuous during the move here. Now we'll talk about why wireless LAN cannot implement CSMA CD. The reason behind that what we have to discuss here, and in the reference towards it, the reason is that the collision detection station must be able to send the data and receive the collision signals at the same time, and in the regard of it, the collision may not be detected because of the hidden station problem. And the third we have is that the distance between the station that can be great signal of fading could prevent a station at one of the from hearing stations at the other end as well. And this is all that we'll discuss here, that is a wireless LAN cannot implement CSA, and that is your wireless LAN cannot implement CSMA CD. So this is all that what we have to discuss about it, and now we'll discuss more over things in the next coming classes, and that what we have to discuss there. And first of all, it's a huge request from my side to all of you, please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And in the case reference towards it, that what we had discussed about it, unit 1, that is introduction concept, we had completed that in the last class. That is the goals in the applications network and the network structures and architecture, the OSI references model, services and network topology design, delayed analysis, backbone design, local access network design, physical layer transmission media, switching method, ISD and terminals handling. The second unit that we are dealing with, that is your medium access sublayer. Medium access sublayer, channel allocations, LAN protocols, Aloha protocols, overview of IEEE standard that we had done, FDDI, data link layer, elementary and the link protocol, sliding window protocol, error handling, that what we have to do in the next coming classes. And in the unit 3rd, we have to complete the network layer, where we have to cover up with network layer, point-to-point network, routing, congestions control, internetworking, and then the TCP IP, that is the TCP IP packets, IP address, IPv6 have to complete it. In the unit 4, the transport layer, that is the transport layer, design issues, connections management, sessions layer, design issues, remote procedural call and prevention layer, design issues, data compression technique, cryptographic TCP IP window as well, that what we have to cover up. And for the application layer, that is unit 5, the application layer, file transfer, access and management, electronic mail, virtual terminals, other application, example network, internet and a public network, that what we have to cover up in the next coming class. So it's a huge request from my side to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information first, and you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give your suggestion on a comment box. Thank you.